Hello, everyone. My name is Rene Vergara, and I am here to present the project that we're currently working, thanks to the support from the Zcash community grants. Our project is Zenith, a full node wallet for the new Zebra node for the Zcash network. So to start, I would like to just have a quick review of what even is a full node wallet. There was some discussion about this both in the Zcash R&D Discord and also on the on some of the light client working group calls, that the difference between a light client and a full node, both need to manage the user's keys, they need to manage the user's addresses, they obviously both need to be able to decode transactions and send transactions. So for the purposes of the Zenith wallet, what we're trying to make the distinction is that our wallet interacts directly with the Zcash node, in this case, the Zebra node, as opposed to a light client wallet that may need an intermediary like lightwalletd to communicate with the blockchain. So why build a full node wallet? So running a Zebra node increases the decentralization of the network. It makes the network stronger and it helps the community. We hope that having wallet functionality on top of that Zebra node will also encourage more people to run their own nodes. Having a Zebra node of your own gives you direct access to the Zcash blockchain. There are no gatekeepers between you and the chain. Having a Zebra node of your own also increases your privacy by not exposing your transaction data to a third party. And many Zcash apps currently rely on Zcashd's wallet functionality to interact with the Zcash blockchain programmatically. So having this capability on the modern Zebra node will give us an alternative for the future for that kind of access to the Zcash blockchain. The goals for Zenith, originally Zenith started as a set of scripts that we were using to test our other applications, Zgo. And over time, it developed enough functionality that we decided, it's probably worth building this up to a more full-fledged product. And with the support of the CCG grant, we decided to move into that direction. Our goal is to be able to give the user a way to manage different sets of spending keys, manage the different addresses that they may have, both as recipients and for any senders. We want to be able to obviously send and receive transactions for the different shielded pools. We also want to focus on ease of use. So the people that try to use Zenith for that purpose of sending the transactions have an easier time to doing it than having to interact at a lower level that may involve using things like JSON or other types of HTTPS encoding of the data. And another one of our goals is to make sure that it's easy to install, because many open source programs tend to have that problem, is that, we have these 17 dependencies that you have to install independently, and that in many cases is enough of a barrier for someone to try an application. So we're trying to build it in as self-contained as possible to make that easier for the users. At a high level, the way our app is built is it's written in Haskell, which is a functional programming language that has a pretty robust ecosystem that gives us a lot of functionality on the UI side and on the interaction with the non-Zcash parts of a wallet. And we've also developed a Haskell library that allows us to leverage the Rust libraries that have been created by the ECC and the Zcash developers, so we can have that functionality, but use it in Haskell and have both the robustness of the Zcash functionality and also all the bells and whistles that we can get out of Haskell libraries. We are currently using a SQLite database as the backend. This is part of our goal of keeping this as self-contained as possible. Many other libraries like MariaDB or PostgreSQL require the user to install their own server and then create user accounts and create tables. And that, again, can be quite a bit of a barrier for someone that is non-technical to install an application. SQLite has the benefit that it is embedded in our application. The database comes with it. You don't have to install anything, and the database will work out of the box. And we are working to interact directly with Zebra. So we have built that code that allows us to plug into the existing Zebra RPC, and that's what we are using to interact with the blockchain. So a couple of definitions, because we're calling Zenith a wallet, but it really is more of a wallet manager application, in the sense that it can support multiple wallets. And so when I'm saying a wallet, I'm referring to a particular seed phrase that someone can use to then generate all the different accounts that belong to that seed phrase. And again, Zenith allows you to create multiple accounts. Each account is a set of spending keys, in essence, which allows you to have different buckets of funds, but they are all still governed by that same seed phrase. You can recover all of those different buckets from that same seed phrase. But at the same time, you can keep those funds separate by using different accounts. And under each account, you can have multiple addresses based on the protocol and all the work that has been done to create the diversified addresses, both unified and inside with the different receivers. So to do a quick overview of the features that we have currently in the app, right now our first milestone for this project was to create a command line user interface that would allow us to have this functionality. So upon starting a brand new installation of Zenith, the app will guide the user through the process of creating their first wallet, in essence, their first set of seed phrase, and then create the first account for that particular seed phrase, and then create the first address for that particular account, which would give you the bare minimum that you would need to start sending and receiving ZEC. Like I said, our app supports multiple wallets. So you are able to create new ones. You are able to switch between them as you need. That gives us that flexibility that you are able to maintain that separation between your different seed phrases. Currently, our application is using unified addresses as the default, but we are exposing the different receivers in their encoding to the user. So a user that may be interacting with a wallet that doesn't support unified addresses yet can still receive funds through the legacy shielded address or through the transparent address. All of these would deliver those funds under the account that generated these addresses. And we have also created the functionality that makes it easy to copy these addresses out of the wallet into anything else where you may need to communicate your addresses to the sender. The app allows us to display the transactions that have been received in the account, and also display the information for each transaction, like the transaction ID, the amounts that have been received, and also any memo that may have been included in the transaction. And the app also allows us to send transactions to Zcash addresses, including unified addresses. So now we can do a quick demonstration of the app. As you can see here, we have Zenith running on testnet. Right now, the first step that we always do is to ensure that Zebra is there, and we're currently working with Zebra on testnet. The UI is designed to use keystrokes to perform different actions. And what we can do to demonstrate is I will create a brand new wallet. And we can call this wallet the ZconV wallet. And now we can create an account. We can call this our demo account. And we can create multiple addresses under this account. And we can main address. So we have created that new address and it's ready to go. We don't have any transactions, it's a brand new wallet, but we can display this address as we mentioned. And I'm just gonna copy this unified address right now, so we can play around with it. So this is what the app would look for someone that just started a brand new installation of it. Right now, we can switch back to a different wallet to explore a little bit more of the UI. So we could try this wallet. As you can see, the wallet presents the balance of the current account. It also displays any addresses that are part of the account and any transactions that are currently being associated with this address. We can switch to these transactions and it will show the inputs and the outputs. And we can also display the details of each transaction. One of the things that has been most helpful during the testing of this has been the testnet faucet from SEC pages. So definitely a big thanks to Michael for that. And now, if we wanted to send a transaction, one of the things that those who are more observant may have noticed is that at the bottom we have a little counter. The app currently is set up to perform a background sync every 90 seconds, and that is about to happen right now. It will download any new blocks that we've received, and it will perform any decryptions, and also all the tasks of updating the witnesses. And we can now try to send a transaction. We can copy the address that we just provided. The app currently validates these addresses. So if the address is incorrect, for example, it will display it to the user that the address is not a valid Zcash address. We can enter an amount and we can send the memo. And now the app will go ahead and start doing the heavy lifting of the cryptography for that transaction. So while we wait a couple of minutes for the transaction to be sent and mined, I was going to go through some of the questions that we've received so far. There were some that we had in advance. So the first one that I have is that with the forthcoming deprecation of Zcashd, what are the plans for how the Zenith wallet will interact with the consensus network? Right now, this wallet is built on Zebra. Originally, we were hoping to have just to be able to use either of the two implementations. But upon more detailed examination, there were some key differences in the implementations of the different RPCs between Zebra and Zcashd. So we decided to focus on Zebra as the future of the node implementations for the Zcash network. We still have the original version of Zenith available in our repo, which was built for Zcashd as a UI for Zcashd. That will remain available for people that are interested in using it, but the new version is built to interact with Zebra. The next question is, will Zenith require a lightwalletd server to send transactions? And we do not. The wallet right now is performing all its pre-processing of the chain on its own, and then using that information to generate the transactions. That was part of, as I mentioned earlier, we're trying to make it as self-contained as possible to reduce those different dependencies and those additional tasks during installation that a user may need in order to do it. Then on the next question that we have is, for an ordinary user, what are the benefits of having a full node wallet? I touched on this a little bit, but I do think it's a good question. I think in many cases, one doesn't stop to really think that when we're interacting with one of these services, it could be a blockchain or it could be anything else like Signal or Discord, is that we are depending on a third party to provide us the service. And if that third party for some reason is not there at any given point, you don't have access to the service. And I think having the chance to connect directly to the service without that third party is of great value for users, and it gives a lot more resiliency to the protocol. It removes those single points of failure, and the more nodes that people spin up, the stronger the network gets. And I think that it provides that benefit to the community that you're running your node, and it also gives you the benefit of that direct access to the chain. And I think that that's a pretty good trade-off for anybody that wants to run their own node. Another question that we have is, will Zenith expose a CLI or an RPC API? And this one is getting a little ahead of the presentation, but yes, that was part of our proposal to the Community Grants Committee. Is one of the goals that we have is just create the UIs to make it easy for someone to use their full node to send and receive transactions. But we also want to be able to provide that access that Zcashd currently provides to access the chain programmatically. So towards the end of our roadmap, one of our final deliverables is the implementation of a set of the RPC methods that would allow someone to, like we're doing right now, send a transaction, create a wallet, create an address, read the transactions that are contained in the wallet programmatically through this API. So that is definitely part of our roadmap. Being a Haskell developer, are you considering building a Cardano Zcash bridge? I have thought about it. I've thought about it. I think it is a potential option of growing the exposure of Zcash. There are some technical challenges that I would need a lot more research to do on my own in order to really understand. I think from the perspective of the coding of smart contracts in Cardano, from what I've read, the Marlow language is pretty straightforward. And I think the challenge, as always with these bridges, I think it's being able to create something that is truly secure and resistant. I think it would be potentially difficult to have something that is just one server that is, that is under, let's say, under my control, where all the ZEC is getting piled up that people are bridging towards Cardano. I think it creates a potential risk that would need to be addressed. I think bridges are tricky in that sense. But I do think that having the overlap is potentially an avenue of growth for the Zcash community. That was part of our goal as well, of developing this Haskell library for Zcash, because the Haskell community is a pretty committed community to building and coding and building interesting things. And there is a group of crypto communities that code in Haskell. In fact, one of the open source libraries that we're using was originally built for a crypto project, because one of the interesting things that is happening in this whole space of Haskell is that many projects that currently run on C libraries are moving to Rust. So now many Haskell libraries that for years have depended on the C libraries and have very good support for that type of interaction are now looking to move to Rust, and that is happening as we speak. The Haskell community is in very serious consideration of improving their support of the Rust language, and I think that will only help our community by integrating all this Rust code that has been already created for Zcash and making it available in the Haskell ecosystem. So I'm just going to go here. The transaction was sent, so we should be able to now switch to our brand new wallet and wait until it syncs, and we should be able to see the transaction arrive on our brand new wallet. While we wait for the sync, are there any other questions that anybody has online? So we have another question. Any chance for developer command line arguments so we can build apps with the wallet? We can definitely look into that. I think that is part of one of the things that I wanted to ask the community as part of the ecosystem is if you have any ideas, any use cases, please make sure that you bring them up. Because for certain use cases, the RPC API may be enough, but if for other use cases, you may need a little more direct access with the application as a command line. So feel free to reach out to us. We are active in the forums, and we can see here that our transaction just arrived, and we can display here this new transaction. This was an Orchard transaction. So with that, we can touch a little bit on what's next. One of the things that we are looking into is performance improvements. I think that's something that all wallets currently are looking into is how do we make this faster. One of the features that we've heard it's been requested is the address book is something that we want to implement to make it easier for users to manage the addresses of people they interact regularly. Because the full addresses can be a little cumbersome. As I mentioned, we are going to build a graphical user interface based on what we currently have on the command line and an RPC server to allow that programmatic access to the wallet itself. If there is a need for something like direct command line access for someone that may want to write, like a bash script that talks to the wallet, please let us know, because that's something that the architecture that we selected for this was that we have the core Haskell functionality, and we can access it in multiple ways, like the command line or the graphics or the RPC server is actually the same core language. So adding different ways of accessing that same core functionality is something we can always discuss with anybody that has a use case that they want to explore. So my call to action to the community is to try to get as involved as you can with the teams and the products that you like and that you use. Feedback is very, very valuable. If you see something that you like improved or do different or implemented in a different way, please feel free to join. I think that's one of the great powers of the Zcash community is that there is actually quite a bit of collaboration. All these applications that I've demonstrated today is built because of that collaboration. The teams from the Zcash Foundation and from ECC are always available to developers like myself to ask questions and clarifications and discuss ideas. The Light Client Working Group has also been a great resource. The Zcash R&D Discord is always available for people to have those discussions and ideas. And I encourage everybody to try to test these products that we are building for the entire community and bring us that feedback. It's one of the most valuable things that we can get as product developers is knowing what works and what doesn't to make it better, because the better it is, the more people will want to use it. So please don't be shy. So we went through the questions that were on the chat. We could wait a couple more minutes to see if there are any other questions. Okay, we do have a new question. How difficult would you consider it for use for a less experienced command line user? What level of experience might be required, maybe compared to Zcash Clean? Okay, that is a good question, because that has always been kind of our benchmark, because we started when we were developing Zgo using Zcash Clean to try to test it, and it was cumbersome. It's complicated for someone that is not technical to try to write the JSON parameters for the call. So I would say it is far more intuitive to use, because it is built towards looking more like a user interface with, rather than parameters to a function, you're just providing the information that you as a user have, which is who's the recipient, what's the amount, what's the number you're sending, and then our application can take care of the rest of encoding the memo and calculating your notes and all of that information. So from that perspective, I do think it makes it a little simpler. One of the things that we are aiming with the application as well is by creating the system that you can pick which wallet you're using, which account you're using, which address you're using within that account through the UI. It makes it simpler that you can just send a transaction rather than having to specify all of those every time that you're trying to send, like you would do on more of a command line type interface. So we're trying to simplify it, but again, if you see something that perhaps doesn't make any sense to you or it's confusing, please let us know, because that's exactly the kind of feedback that makes the application better and more user-friendly. We have another question. What policy does Zenith follow for use of shielded and transparent addresses? Does it hold funds as shielded by default, or does it leave it completely to the user to what kinds of transactions to create? Okay. So right now the wallet, what it's doing is it's not shielding anything proactively, but it is set so any change from a transaction is being shielded into the orchard pool. And I understand that for some use cases, some people would prefer to be able to have a lot more granular control of that and decide where that goes. We implemented it that way right now with the intent of making it a simple way of people keeping their SEC and also over time shielding it, because the more transactions they send, the more change is going to end up in the orchard pool. As part of our upcoming milestone, and also supporting of Z320 and the exchange addresses, we do need to implement functionality to provide a more user-driven shielding and de-shielding of funds. And that's something that is on our roadmap, because it is going to be a key functionality to support those text addresses. So right now, it is set to shield over time via the change notes. But if there is some use case or a particular setup that people feel like should be supported, please feel free to let us know, and we can start working to be able to provide it. So there's another question that the amounts are shown in mZEC, mTAZ. What was the rationale for that decision, and is it configurable? Well, that is something that we implemented in our first original version of Zenith as a way to simplify the reading of the transactions, because if we just set everything to 8 decimal places, sometimes it can be a little cumbersome to sit down to start counting zeros to see exactly how much did you get. Right now, it's not configurable, but we can definitely look into setting it up. Right now, the way it's set up is that if it's big enough, it'll show it in full coins. If it's less than that, it will show you in mZEC. If it's less than that, it'll show it to you in microzecs. And if it's even less than that, it'll just show you in zats. And the idea is to try to keep the numbers in the range, in the hundreds, to make it a little more readable. I grew up in the metric system, so I like millis and micros. So, but again, it's one of those things that makes perfect sense to me. But if people prefer something else, we definitely would like to hear that feedback. All right, there's another question. How do I install? Where do I see the instructions? Yeah, so we have our repo in our website, and I can make sure to, as part of this presentation, we are in essence providing the first milestone for the project. So I will post this on the forums as well as our update with links to the code and the installation. Right now, there are some dependencies. You need to install Haskell, install Cargo and Rust and a few things, but it should be fairly straightforward. And all those instructions would be available in the README of our repo. We are also working towards the later milestones of the project to move from that to something that is even a little more packaged, like maybe something like Docker, that would allow it to make it even a simpler installation. All right, so if there are no other questions, I just want to thank everybody, and thank you in advance for any feedback and for participating in ZconV.